So I'll talk about the Extragalactic notebook from ALeRCE, where it's a notebook that we prepared with Paula Sánchez. So we will switch in the middle of the presentation. I recommend you to visit these 3 publications that talk about the project, the real-time stamp classifier, and the LightCode classifier. So here we'll just first use the client to do some Kubernetes science, and later Paula will talk about AGN science using a direct connection to the database. So after connecting to the API, installing the client, initializing the client, we will first do some queries to particular objects. So we will use this object ID. Okay, so you can look at the Explorer, and we will query the object table. So here you will see what you get for this object. You get many statistics. For example, the mean right ascension and declination, the first and last detection times and magnitudes, colors, etc. So that's the first table. Then there is a table where you have aggregation per band. That's a maxstat table, and for this you query maxstat with the object ID, and we also use pandas. We like pandas. We have statistics per band, G and R band, the mean, the median, etc. The first and last detection, magnitude and time, etc. Note that FID is a unique identifier per band. Then we can query detections. And here we get the LightCode basically of this object in different bands, where candidate ID is a unique identifier per detection. You get also whether the difference is positive, the limited magnitude, the distance to the nearest source. And one thing you can see here is that if the distance to the nearest source is less than 1.4, then we also give you the corrected magnitude, assuming a reference magnitude. We can also query the non-detections with this query non-detections method. And we can query probabilities or scores. In this case, we do query probabilities for this object ID. And what we get is a data frame that contains the probabilities for all the classes. But I'm only interested in those that are the most likely. So that's the ranking column. And for the stamp and LightCode classifier. And so what I can see here, a summary for this particular object, according to the LightCode classifier, is most likely a type 1a supernova, and according to the stamp classifier, is most likely a supernova. So you see that the LightCode classifier has a finer taxonomy than the stamp classifier. Then we can plot the stamps. What we see here is basically something that is a bit extended. That's why the stamp classifier classified as supernova, and this is the difference of the first image stamp. You can also query any particular candidate ID for different times. Then we build a function to plot the light curve, assuming that we have the redshift, the attenuation, and yes, these two quantities, and a function to get the redshift and the attenuation. In this case, using irstadust, and also using net. So we automatically get the redshift. So we get the table just to confirm that this is correct. And we plot the corrected, the attenuation corrected light curve and the original light curve in apparent magnitudes and in absolute magnitudes, assuming no K corrections in this case. Then one thing else that we do is that we have features. So we also have many features. In fact, we have 86 features per band. And this you can get with the query features method. So here you can see there's 172 features, but there are 2 bands, so it's 86. And in particular, I'm interested in the features that are used in this parametric model. This is the supernova parametric model that was introduced by Villar in 2019, and that we modified in order to make it easier to converge, to fit in real time. So what we use is basically something like this, but where the transition is not doesn't have a discontinuity, we use a sigmoid function to do it more smoothly. And so here I can look for all the features that start with SPM, supernova parametric model, and here they are, and per filter. And so I get the amplitude, some parameters related to the rise time, etc. And if you want to know more, there's 3 more notebooks about supernova, forecasting, and the watch list. And now I pass to Paula.
Thanks, Francisco. Okay, so can you see the, okay.
Yes.
So now I will continue with AGN science that you can do using ALeRCE. And in this case, we will connect directly to the database. So as mentioned in other tutorials, we have these read-only credentials. So you can go to this repository and see the credentials. And we connect to the database using this package, scopd2. Okay, so this is a summary of the tables that are available in the database. Lorena yesterday already explained this. Just to mention, we will be using detections, object, probability, and features today. Okay, and so related with active galaxies or AGNs, we have three classes in the ALeRCE Likert classifier. The first one are AGNs or type 1 Seyfert galaxies, which means objects dominated by the host galaxy. Then we have quasars or type 2 nucleus-dominated galaxies, and blazars, which are jet-dominated sources. Okay, so we will do a query to search for AGN, quasars, and blazar candidates using the Likert classifier. So to do this, we need to make a join between the object and the probability tables. So in this case, we just query objects that are classified as AGN, quasar, or blazar with a probability higher than 0.5. You can here select your own probability cut. And since these are AGNs, we are also requesting a time span of 200 days or larger and 30 detections. Okay, this is very important because AGN show variability in longer time scales compared to other classes, so we use these cuts. So after this query, we obtain this pandas data frame with the object IDs and some statistics about the source and the probability. So if you want to know how many sources are classified in one of the classes, you can do this. So we have several quasars and a few blazars. And we will keep the object IDs of these candidates, so we can then query the features table. So in this case, we use the already saved object IDs to make this query to the features table, and you get something like this. But this table is not very easy to manipulate, especially if you want to plot features. So what we do is to parse the data frame in this way, where we add number 1 for the G band and 2 for the air band. And we also put everything in a way that each column corresponds to a feature in a particular band. So I really recommend you to use this in order to make plots. If you want to make plots, you need to do this. Okay, so we now join this features table with the objects table we already obtained in the previous step. So now you have everything in one data frame. Okay, thanks. And now we will plot some important features related with AGNs, which are the lamp random walk features. So this model was proposed a long time ago by Kelly et al. 2009, where they proposed that we can use lamp random walk modeling to fit AGN Likert. We have two important parameters: the time scale of the variability, which is this tau parameter, and the amplitude of the variability at short time scales, which is this sigma parameter. Okay, so if we plot this for the AGNs, quasars, and blazars, we obtain this. Okay, so in blue you have quasars, in red AGNs, and in green blazars. So the physical interpretation of this is that quasars tend to have longer time scales of the variability, and this is related with the fact that they have larger black hole masses, and they also have shorter amplitudes, and this is related with the fact that they are more luminous. AGNs are in the middle, and blazars are the one with the shortest time scale in the variability. This is because we are observing the jet, not the accretion disk, and they also have a larger amplitude in the variability. Okay, so this is the reason why we can use optical variability to separate these three classes. And this was already proposed by a previous paper in Ragnar et al. 2012. And if you want to see more details about this AGN science that you can do with ALeRCE, you can go to this notebook. It includes more examples of how to plot lie curves, how to use the database to get band stars information, etc. That's all. Thanks.
Great, thank you. So again, let's post questions in the Slack channel.